And now the James Webb Space Telescope is identifying objects in the dark ages that, by best measurements we have, are large, fully developed galaxies.
We can now go ahead and start exploring because the James Webb Telescope has finally found the edge of the universe. Astronomers have used the James Webb Space Telescope to explore the early universe and have found something they didn't expect. The Space Telescope found 6 very large galaxies that were around 500 million to 700 million years after the Big Bang, which created the universe. According to a new study published in the journal Nature, the finding is completely changing how people thought about how galaxies were made. In what was once thought to be the early universe, these things are much bigger than anyone thought they would be. Scientists were surprised to find galaxies as old as our own, when they thought they would only find tiny galaxies that were just starting out. This telescope looks at the sky through infrared light, which is a wavelength that our eyes can't see. It can pick up the faint light that old galaxies and stars give off. By looking into the very faraway space, the observatory can go back in time to about 13.5 billion years ago. Scientists think the universe is about 13.7 billion years old, so this is really cool. What many of us thought was proven science has been turned on its head by the finding of this huge galaxy formation that began very early in the history of the universe. Our slang term for these things is universe breakers, and so far they've lived up to their name. Now, scientists need to rethink how galaxies formed and developed because they are so big that they don't agree with 99% of models that describe how galaxies formed in the early universe. The most common theory says that galaxies began as small clouds of stars and dust that grew over time. They looked into the very early world for the first time, but they had no idea what they would find. For some reason, what we found was so unexpected that it actually makes science harder. In fact, it calls the idea of how galaxies formed in the beginning into question as a whole. Researchers began looking at the Webb data and the first high-resolution pictures of the telescope as soon as they were made public in July 2022. The team was shocked to find the galaxies. They were so shocked that when they first saw them as big points of light, they thought they had messed up the data. As soon as they got the information, everyone jumped right in, and these huge things showed up very quickly, almost like they wanted to be found. One way to find out why, how, and when the galaxies formed is to take a spectrum picture of them. This is done by splitting light into different colors to identify different elements and guess how far away the galaxies really are. The spectroscopy readings help us learn more about these huge bodies, and a spectrum will tell us right away if these things are real, how big they are, and how far away they are from Earth. It's funny, because this wasn't even close to being the most important thing we wanted to learn from James Webb. Scientists didn't know what they found, but here we are. It also happened a lot faster than experts thought it would. It's also possible that the galaxies found by Webb are not what they seem to be. It's important to keep an open mind about what we're seeing since this is our first look back so far. These objects could be galaxies, but the data makes it more likely that they are not. Some of them could be secret supermassive black holes. Let me tell you something amazing. The mass of stars is up to 100 times greater than we thought it was before. Even if we split the group in half, this is still an amazing find. A group of astronomers from around the world used data from the James Webb Space Telescope to find the oldest and farthest galaxies that have been proven so far. The telescope picked up light from these galaxies more than 13.4 billion years ago, which means they were formed less than 400 million years after the Big Bang, when the universe was only 2% as old as it is now. The first observations from JWST showed a number of possible galaxies, just like the images made with the Hubble Space Telescope. Now, long-term spectroscopic observations have confirmed 4 of these objects. These observations not only let scientists study the galaxy's physical properties, but also give them a good idea of how far away they are. Astronomers can figure out how far away a galaxy is by finding its redshift. You ask, what is that? The Doppler effect makes the light from far away things longer and redder, making it look like the universe is expanding away from us. Redshift estimates can be found using photometric methods with pictures taken through different filters, but precise readings need spectroscopy, which separates an object's light into its individual wavelengths. The new things that were found are mostly about 4 galaxies with redshifts higher than 10. The redshifts of the 2 galaxies that Hubble first saw have been proven to be 10.38 and 11.58. 2 galaxies that have been proven to be very far away by spectroscopy are those found in JWST images. They have redshifts of 13.20 and 12.63, which mean they are very far away. Redshift 13.2 tells us that the event happened about 13.5 billion years ago. Two of Webb's devices, the near-infrared camera and the near-infrared spectrograph, were made by scientists who worked together to come up with the results. Also, the JWST Advanced Deep Extragalactic Survey is a big project that has been given a little more than a month of the telescope's time. Its goal is to give us a look into the early universe that has never been seen before in such depth and detail. The instrument teams got together in 2015 to share their ideas for the project. It was made up of more than 80 experts and scientists from 10 different countries. It was called JADES. The JADES study began with NIRCam and spent more than 10 days watching a very small part of the sky in and around the Hubble Ultra-Deep Field. Astronomers have been looking into this area for more than 20 years with almost all large telescopes. The JADES team studied the field in 9 different infrared color bands and found almost 100,000 very far-away galaxies. Each one is billions of light-years away. The scientists then used the NIR spectrograph to catch light from 250 weak galaxies over the course of 3 days of observations. It was shown what the gas and stars in these galaxies are like, and exact redshift values were found. With these measures, we can find out how bright the galaxies are on their own and how many stars they hold. Now we can fully study how galaxies are put together over time without having to know how they started to grow. Like people, it can be hard to understand how a galaxy works. Later events are affected by the effects of these early star generations in a big way. Now is the most exciting time ever. The revolutionary power of Webb is answering a huge number of questions about galaxies. Some of the first stars would have formed about 225 million years after the Big Bang. This is because star formation began in these young galaxies about 100 million years before they were found. NASA's Deep Space Research Telescope is giving us a new view of the universe, and we found a lot more. The James Webb Space Telescope has found amazing new details about galaxies, planets, stars, and many other interesting things happening in space. It is a leader in scientific study. The telescope was launched in December 2021 and is meant to work for 20 years. It is just beginning its trip through space. Webb, which is being sold as the successor to the Hubble Space Telescope, is also getting people more excited about science than ever before. People from all over the world are sharing photos of the raw data and getting new ideas from them. Do you remember how in February 2023, Google, the biggest search engine in the world, used a Webb question to test the new Bard AI bot? Bard sadly missed the simple fact that Webb wasn't the first telescope to take a straight picture of an exoplanet. But this telescope found many other amazing things as well. For example, NASA scientists and engineers worked on Webb for years before it was launched on Christmas Day in 2021. The next few months saw the stages of putting the telescope in place go off without a hitch as well. Webb released its stunning first pictures in the middle of July. With the help of the infrared camera, these pictures let us see almost every part of our universe, even the farthest galaxies in more detail, giving us a look into the past. As soon as the telescope went online in late June 2022, scientists began finding thousands of new galaxies that were older and farther away than any that had been known before. Some of these galaxies may have been found more than 150 million years before Hubble found the largest one. The camera can also gather enough light from objects in space, like exoplanets and new stars, to figure out what they are made of and how they move through space. This information has already begun to show in great detail the atmospheres of planets hundreds of light years from Earth, shedding light on whether or not they might be able to support life as we know it. The James Webb Space Telescope found what may be the oldest black hole in the universe by looking at tiny wisps of light from very close to the beginning of time. The supermassive black hole, which is 10 million times the mass of the Sun, was found at the center of a young galaxy 570 million years after the universe began. This was possible thanks to the telescope's powerful cameras, which let it see into the very beginning of the universe. During the cosmic dawn, which started about 100 million years after the Big Bang and went on for 1 billion years, many black holes got bigger. The cosmic monster may be one of them. Even back then, scientists didn't know why there were so many of these black holes or how they got so big. Telescopes can see light coming from some of these huge holes in space-time because the material falling into them gets hot from the friction. Active galactic nuclei, AGN, are the name for these things. As the name suggests, quasars are the most intense type of AGN. They are billions of times heavier than the Sun and shoot out light blasts that are trillions of times brighter than the brightest stars. Light moves at a steady speed through space, so as scientists look deeper into the universe, they catch light from farther away and can see earlier times in the universe. The mid-infrared instrument and near-infrared camera on the JWST were used to look for the black hole in the sky. The spectrographs on board these instruments were used to split the light spectrum into its different frequencies. By studying these weak signals from the early universe, they found an important sign that the hot matter surrounding a black hole was sending weak signals of radiation out into the universe. This was done by noticing an unexpected rise in the frequencies of the light. It's still not clear why black holes formed so quickly in the early universe. The search for much younger primordial black holes that are thought to have formed right after the Big Bang, or even earlier, is still going on, but we haven't found them yet. Do not worry, there are two main reasons why there are so many black holes right now. Either they are the remains of huge stars that formed much faster than the stars we see today, or they are clouds of very dense gas that suddenly fell together to form the all-eating singularities in space-time. Scientists think that the first population 3 stars formed 200 million years after the Big Bang and were made up of only hydrogen and helium. It is more likely that one of these stars exploded and created a black hole before quickly gathering a lot of matter and growing to the size that scientists saw. Scientists will start working together with the people who made MIRI to look for a light source from a galaxy far away that is even stronger. These fumes might hold more clues about how the mysterious black hole in the center of the galaxy came to be. They have also looked back into the early stages of the universe and seen a protocluster made up of 7 galaxies that were interacting with each other. Scientists have found the farthest galaxy cluster. Based on computer models, the system will have grown to be one of the oldest and largest known galaxy clusters in the universe, with a mass almost 100 times that of the Milky Way. The 7 galaxies were first found by the Hubble Space Telescope, but it wasn't accurate enough to measure the exact distance between them, even though they were all seen from the same point of view. Imagine being in the sky above Los Angeles and looking out the window through a telescope. You could see Phoenix, Dallas, and Atlanta, but you wouldn't know how far apart they are, right? But with the help of the James Webb Telescope, we could see things much better. Scientific experts say that these kinds of groups are very rare and hard to find. Now, it's not likely that JWST will help us find another unique system like this one. Unfortunately, the telescope we have can only see small parts of the sky. We need one that can see a wider area. It will be possible to make discoveries like these in the next 10 years thanks to the Nancy Grace Roman Space Telescope, which NASA hopes to launch in early 2027. Wide area surveying will be easier because it will be more than 100 times better than JWST. This will help find galaxy groups in the early universe like the one found in this study. Anyway, let's get back to what the JWST found. In the 1990s, it was this revolutionary telescope that helped scientists find the first exoplanets. It is now known that there are more than 3,000 worlds outside of our solar system, but only a dozen of these have been captured directly. Most exoplanets are so far away that they can only be seen when the planet moves in front of their mother star and dims its light. Webb made that different. In 2017, the planet was found and given the name HIP 65426b. Scientists used 2 of Webb's cameras, a number of filters, and other tools, along with the telescope's coronagraphs, which blocked out the light from the middle star, to look at it. Not only is the planet very sensitive in telescopes, but it also has a number of features that make it easier to see. This planet is 100 times farther away from its star home than any other planet in our solar system. Just to give you an idea, Pluto is only 40 times farther away from the Sun than Earth is. This alien world is a gas giant that is about 12 times the size of Jupiter. The Ghost Galaxy is hard to spot in the night sky, but its brightness can still be seen, especially in pictures taken with Webb's infrared camera. Hubble's visual view of the object, which is also known as M74, shows the galaxy's beautiful spiral shape and how the arms of stars spread out from a bright center. Also, Webb's picture of the universe showed structures that look like threads. They are made of dust and gas that give off heat and come from a bright center that is a striking electric blue color. The infrared lighting feature of the picture lit up places where stars are being formed all over the spiral arms of the galaxy. Then, pictures from the Hubble Space Telescope and Webb were put together to make a beautiful new picture that shows parts of the galaxy in both visible and infrared light. Researchers made the composite picture as part of an international project that uses Webb, Hubble, and a number of ground-based cameras to take pictures of 19 nearby galaxies that are still forming stars in the infrared range. A movie showed the three pictures so that they could be compared side by side. Thanks to Webb's studies at longer wavelengths, scientists were able to find galaxies in areas where stars are being born, figure out the masses and ages of star clusters with greater accuracy, and learn more about the properties of the very small dust particles that are moving through interstellar space. Webb also took a picture of a Wolf-Rayet star, which is a very faraway star, with a unique diffraction pattern that is caused by the camera. The WR-140 star is ringed by a pattern that also doesn't seem real. A series of concentric rings that look like waves and have an odd, slightly boxy shape. In contrast to the diffraction pattern, the rings with their strange shapes are real features. These big stars are getting close to the end of their lives and have already sent a lot of hydrogen into space. The strange forms of the ring are caused by the interaction between WR-140 and its small companion star. The cloud of dust has been shaped into the shape of their neighboring star. Also, thanks to Webb, the planet that has been studied the most outside of our solar system is one that orbits a star in the sign Virgo. That world is 700 light-years away from Earth and is called WASP 39b. That star is home to a hot gas giant about Saturn in size that orbits around its host star 8 times closer than Mercury is to the Sun. For one thing, Webb was made to explore the edges of the universe, and scientists have proven that it did just that and more. What do you think about these discoveries? Tell us below and don't forget to subscribe for more.